Hey there everyone, welcome back to another video. Today we'll be looking at the mole concept. So let's look at what a mole is. A mole of a substance is the amount of that substance that contains the same number of particles as there are 12 atoms in 12 grams of carbon 12. The unit is in mole. Okay, so the number of particles in a mole have been experimentally um, come in? Yes, have been experimentally determined as 6.022 times 10 raised to the power 23, which is also known as the Avogadro's number. We all know that in a dozen, when we say a dozen, we know that it's 12. Similarly, when we say a mole, it is always going to be 6.022 times 10 raised to the power 23. So it could be atoms, molecules, or formula units. It depends on what you're trying to imply. Moving on. Okay, so this is the key equation that you must remember. Mathematically, the mole is mass or molar mass. So mass. So sometimes you may be given the mole, and sometimes you may be given the mass. So it depends on what you have been given and what you're supposed to find. Sometimes you'll be given the mass, so you do mass over molar mass, and sometimes you'll be given the mole and be asked to find the mass, so you do molar mass times mole. Okay, makes sense. Let me just clear this up. Okay, molar mass. So what's the molar mass? The molar mass is the mass of one mole of a pure substance. Remember that it is the mass of one mole because it will help you as we move ahead in the video. Molar mass is usually written in the units grams per mole. So we have mole equals to gram. I'm writing the SI unit, the units by the way. So gram or gram per mole. Okay, makes sense. Let's go ahead. Calculating amount of substance or mole. The mole can be calculated either using the formula method or logical reasoning. How many moles of substance are present in the following? Basically, what you do is 0.05 all over 100. The MR of CaCO3 is 100, that's why. And when we do that, you get our answer 0.0025. Similarly, you can do that with the next question. Do it and let me know in the comments what your answers are. I'll confirm them. Okay, moving on. Yes, so this is it. Okay, so substance, mass, and MR. So we have our substance NaOH, its mass and MR. What you do is the mass over MR, so that becomes 80 over 40. That gives us 2 moles. So that's how you basically find the moles. Hope that's clear. Let's look at reacting masses. It is possible to know the relationships moles equal to mass over MR to deduce the masses of reactants and products that will react with each other. When performing calculations involving reactant mass, there are two main points that must be taken into account. The total combined mass of the reactants must be the same as the total combined mass of the product. This is known as the law of conservation of mass. So that's something you must remember. But then, for now, if you're in grade 8 or grade 8, you don't really need to pay special attention to this. As you go ahead in your classes, you'll be taught more about it. Okay. The ratio in which species react corresponds to the number of moles and not their mass. Masses must therefore all be converted into moles, then compared to each other, and then converted back. So this is the reference to mole ratio. Mole, let me write it down. Mole ratio. So they are saying that whenever we have been, let's say, given the mass and we want to find the move or mass for a different reactant or product, we must first convert that thing, the mass to mole, and then we use mole ratio and find the mole of that product or reactant, and then you convert that back to mass. And that's okay, but we'll look at this as we move ahead in the video, don't worry. Okay, what is the mass in grams needed to prepare the following solutions? Okay, so we have been giving our mole. We know our MR is 100. So you do 0.0025 times our MR, which is 100. I'm not writing the units over here, but just remember to add the units as well. So when you do this, you get 1 and 2. So becomes 1, 2. So it becomes 0.25 gram. Another way to remember this is, since we know that the molar mass is gram per mole, and when it is multiplying by mole times mole, so the mole and mole will cancel each other, leaving the gram behind. So that's another way you can use remember that. Moving on. um Sorry, let me just check. Bring this here. Yes, we were here. Okay, so this is the answer. Yep, we got it correct. Sorry. Okay, moving down. Okay, so we have our substance here. We have been given the amount or the mole, then we have been given the MR. So you multiply these two and then you get your mass. Simple. Let's move on. The Avogadro's constant, or the Avogadro's number, LONA. The number of particles in 1 mole of a substance is 6.02 times 10 raised to the power 23. This is known as the Avogadro's number L, as discussed. So which means that 1 mole of a substance is 6.02 times 10 raised to the power 23 particles. So the number of particles can be calculated by multiplying the number of moles by Avogadro's number. Okay, so it makes sense. Let's say we have 1 mole. Since 1 mole is this many particles, if if the mole increased by 2, so we know that if 1 is this, then 2 will be times 2 of this. That's how we can get the number of particles, uh as I said, by multiplying the number of moles by Avogadro's constant. Yeah, so this is our mole and then this is our Avogadro constant. This is our mole. Sorry, I know that's confusing. Wait, let me just go back. So we know this is our mole, and then let's say 2 was that's our Avogadro's constant, sorry. Then we know that this is our mole, so you multiply this and then you get your number of particles. So we have an equation for this as well. To find the number of particles, you do the number of moles times L. L is our Avogadro's constant, remember? Boom, boom. Okay, okay. We are done with this page as well. Moving on. Okay, so we have this triangle as well, which helps us remember particle is equal to mole times Avogadro's constant. So to find the Avogadro's constant, even though it's going to remain the same, you can do particles over moles, and to find the moles, you can do the number of particles over Avogadro's constant. Yes, I think that should be clear. Okay, these are questions for you to practice. Um, this is our assignment. So 1, 2, 3, 4, and 5. Practice these questions. Um, Moving on to molar gas volume. Avogadro's law of gases states that equal volume of gases under the same condition of temperature and pressure contain equal number of molecules, which is N. This means that 6.02 times 10 to the power molecules of all gases at the same temperature and pressure will occupy a certain specific volume. I'm sorry. Okay, so this specific volume is the molar mass and it is 24 dm cube, or 24 liters, or 24,000 cm cube at room temperature and pressure. Okay, so the molar gas volume will always be 24 dm cube. So now there's the trick over here. In almost all the questions, you'll be given your question in cm cubed. So let's say 25 cm cube. So what you need to do to get converted to dm cube is divide it by 1000, and whatever you get, that will be your answer in dm cube, and then you can continue with whatever the question asks. Okay, so these are some of the formulas here. If 1 mole equal to Vm, then n mole equal to V. So basically this is the formula: number of moles equal to the volume all over 24 dm cube. 24 dm cube. Yes, so V is the volume of the given gas, and then Vr is the molar volume, which will always be 24. Makes sense? Here are some practice questions. So we have hydrogen. The amount of that gas is mole. So you can do. Okay, let me scroll up and tell you one more thing. Okay, sometimes they might ask you to find the volume of the particular gas, so you can do 24 times the number of moles and you get your volume. That's clear. Let's move on. Okay, so what we have been given the mole, and we know that the molar volume is 24. So we multiply this and you get your answer. The same for the rest of them. I hope it's clear. Let's move on to the next page. This one is done. Okay, let's go. Oops, sorry. Let's go here. Calculating the moles in a particular volume of gas. Okay, so let's say we have our gas and then the volume has been given. So we know that to find the mole of any of any gas, we can do the volume of the gas over 24, and once we do that, we get our answer. Yes, the same for the rest of them. Look at them once. Sorry, just look at them once before you continue for the video and look at them. Moving on to assignment. Assignment is questions for you all to solve. So questions, solve them, and then let me know in the comments below. I'll mark your answers. Moving on to mole ratio. So mole ratio is a very important topic. Pay special attention. So mole ratio. Let's move on. Okay, it is a relative amount of any two substances involved in a chemical reaction. Different amounts of substances can react and be formed, but the relative amount or the mole ratio are always the same as that in the balanced equation. So we have our balanced equation here in the mole ratio. We can look at the number of moles by looking at the number here before the compound. So we have 2 over here, so that means there are 2 moles of HCl, 2 moles of NaCl, 1 mole of Na2CO3, 1 mole of CO2, and 1 mole of H2O. Okay, suppose that they are giving you then moles of what do you say Na2CO3. Let's say it is 2 moles. So to find, and then they tell you to find the mole of, let's say, HCl. So we see that it's the mole ratio is 2, and let's say if it's 4 over here. Oh, sorry. Uh, Razor. Yes. Um. Okay, let me use the black color. So we know that it's 1 mole here and 2 mole here. So to find the mole of N, right, HCl, you do ratio. This is where the ratio comes in, is the mole of Na2CO3. So we know that it is 2 is to 1, 2 is to 1. So this could be written as 2 over 1 times the the moles that were of the Na2CO3 times 2. 2 times 2 over 1 will give us 4. So the answer will be 4 moles for HCl. There was just an example. And always remember that the moles that you're looking for, the which substance moles that you're looking for will always come first. Moving on. Okay, I've basically explained mole ratio. And you can pause the video and look at this as well. But then yeah, it's the same thing. Moving on, mass calculations. Okay. So first of all, you find the number of moles of the substance you're told about. Use the equation to find out the moles of the substance, and then find the mass that you're asked. Okay, mass of ethyl. Okay, yeah, this is easy. I think we have already talked about this. You can do this as well. And without wasting time, let's just finish this thing quickly. Okay, these are just question and examples. Okay, yes, this is the main thing here. Okay. Quantity of a solute. A solution is homogeneous and blah blah blah. I mean, you know this. You have come so far in chemistry by now. You're supposed to know this. Let's look at concentration. Concentration. You have two types of concentration: amount concentration, and then mass concentration. This is density. Okay, moving. Amount concentration is the amount of substance dissolved in 1 dm³ of solution. Okay, sorry, let's go switch back to red. The unit is mole per dm³ or mole per liter, or just m. That's the symbol. So to calculate concentration, you do the number of moles all over the volume that you have been given. Mass concentration, it is the mass of a substance dissolved in 1 dm³ of a solution. Unit is gram per dm³. So you do your mass over your volume. You can also find your density by the concentration times mass, C times M. Mass concentration is also called mass density, as I said it already, and expressed in the units gram per centimeter cube. Okay, moving on. We have an example here. Just pause the video and look at the example as well. Let's scroll down. What is next? Okay, we have this much to cover. Let's finish this fast. Okay, finding the concentration. Okay, yeah, these are just questions as well. Let me just finish explaining, then we'll look at the questions as well. Oops. Come down. And okay. So over here, all we have is the assignment. Pause the video and do the assignments as well. So, finding mass. Okay, limiting reagents and reactants in excess, very important topic. So the limiting reagents is the reagent that is completely used up during the chemical reaction. The reaction that is in excess is the reactant that is not completely used up during the chemical reaction. That is, there is some of the reaction left over. Deciding which reactants are the limiting reagents and limiting and reagents in excess. Sorry. Okay, so what you do first is you write the balanced chemical equation, then you calculate the available moles of each reactant in the chemical reaction. Use the balanced chemical equation to determine the mole ratio of the reactant in the chemical uh, reaction. Compare the available moles of each reactant to the moles required for the complete reaction using the mole ratio. The limiting reagent is the reactant that will be completely used up during the chemical reaction. There will be some moles of the reactant in excess left over from the reaction has gone to completion. Okay, so to find which reactant is limiting or excess, let's say that we have been told that the moles of NaCl, let's say 2 over here, are 5.5. So what you do is you do your 5.5. First you calculate for the 5.5 or the mole, or you may be given 5.5 over the number that is over here. So over 2. And then you get the answer. Then you get a particular answer. Then you compare all the answers. The one which is the least is the limiting reagent. And the one which is the most will be the limiting uh, reactant that's in excess. Always remember this is in the, what do you say? Uh, Okay, so this is where you have your products and this is where you have your reactant. So you only need to calculate for the reactants. You don't need to calculate for the products because they say which reactants, not which product. Yes, easy, understood. Let's move on. So we have some examples over here. Okay, example. Masses of reactants given. Okay, example. I want to just look at like the formulas so that once we are done with that, we can come and do this as well. Okay, type of chemical formula. Oh, this is easy. Chemical formulas we have empirical, molecular, structural. Structural we have displayed, and then displayed and written, I think. So first of all, empirical formula. Empirical formula is a formula that shows the simplest whole ratio of the atom, type of atom or element in a compound. And molecular formula is a formula that shows the actual whole number ratio of different types of atoms or elements in a molecule or compound. So this and this are, sorry, yes, so this eh, cannot be further simplified. So this is our this could be our empirical formula, which could be derived from, let's say, C3H9 could be derived. This C2H6 is the molecular formula. When we convert this to empirical formula, it becomes CH3. Yep. Okay. Yes. This is here, and this is changed to this. Okay. Hope that's clear. Structural formula is just displayed over here, so you can just count. So two, so C2, 1 2 3 4 5 6, H6. Yes, this was our empirical molecular formula earlier. So this can be written as CH3 in empirical formula. Easy, makes sense. Let's moving on. Determination, determining empirical and molecular formula. So first of all, you calculate the moles, divide them through by the least mole, and then find the ratio. Yes, I think. Sorry. Wait. Let's go back. I think I misclicked. Um, let's wait for it to come. Okay, so I think we were here. Let's scroll in. Okay, yes, I think I explained this. Okay, so these are just questions, and okay, the main part which a lot of you are confused with, percentage yield and percentage purity of a substance. Okay, nothing much. The theoretical yield of a product is the maximum amount of product that can be produced from a given amount of reactant. In most chemical reactions, the measured amount of a product obtained from a reaction is less than theoretical yield. That is called the actual yield. Percentage yield is the ratio of the actual yield to the theoretical yield multiplied by 100 reaction blah 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 blah. Okay, so what this is basically saying is that so for percentage yield, what you do is that a particular mass will be given to you, that which is your theoretical, wait, is it actual mass or theoretical mass? I think it's actual mass, which will be here, actual. And then you're using the reactants and products and the moles and everything. You have to find your theoretical. And then since it's percentage, you multiply this by 100, sorry, and then you get your percentage yield. Um, yep, makes sense. Okay, a reaction may not always yield the total amount of product predicted by the equation. Okay, as I was saying, actual mass obtained over calculated mass times 100. Easy. Let's move on. These are just some examples, example, and then percentage purity. Yes. Okay, percentage purity is when we make something in a chemical equation reaction and separate it from the final mixture, it can still have some amount of other substance mixed with it. It might be impure. The percentage purity of a substance describes what proportion of that sample by mass is composed to be specific compound or element. So what you do is the mass of the pure product all over the mass of the impure product obtained times 100, and that will give you your percentage purity. I think that is it for this video. Let's check if there's anything else left. um nope, nothing else left. Okay, empirical formula and math, those are just questions. So I think that'll be all for this videos. I hope it's helped. The more concept has been quite a challenging topic for a lot of students, so I hope the video helped. Make sure to like, share, subscribe, and do comment on how you found the videos. Thank you, and see you in the next video. Till then, ta